Hey, happy Wednesday, Lee Legends. I hope you're having a great day. This is Mr. Cherry, and I'm here to explain this new function. It's called an exponential function. And if you remember, when we studied linear functions, we learned about that equation y equals mx plus b. Well, today we're going to be learning about this new equation, and it's like y equals mx plus b, but this equation is for exponential functions. So this exponential function is of the form f of x equals a times b to the power of x. And what we're going to be exploring today is we're actually going to be exploring how changing the values of a and b affect the way that this curve is changing. And so the first thing that I want you to notice is that right now I've set our b value, or our base, at 2, and our multiplier is at 1. And as I shift b, after I shift b, I want you to pause it, and I want you to just think to yourself, how did changing the value of b change the shape of this function? So watch this a couple times. I hope that you notice that as I changed the value of b, that the direction of the curve shifted. So as I move to the right here, so meaning as b gets bigger, what I noticed is that the curve was still growing, but it was growing faster. And as I go backwards, so again, here was 2, that was kind of our set start point. As I go backwards, what happens is at 1, I get a straight line. And as I go behind 1, or go lower towards 0, what happens is the curve shifts direction. So instead of increasing, the curve decreases. And then at 0, there's no curve, because 0 times anything is 0. So the idea is when b is less than 1, you're going to get a decreasing exponential function. And when b is greater than 1, you're going to get an increasing exponential function. All right, so now we're going to explore what a is doing. And if you look right now, I have set our a value at 1. And you can see here that this purple point, our y-intercept, is at 0, 1. And so I want you to just watch this. Watch what happens as I shift the value of a. So as I increased a, I want you to notice what's happening to the graph. This is pretty cool to me. And so I want you to think for a second. You can pause the video right now, and I want you to think about what happens as we shift a. What are we doing? What things does it change? The first big thing that I notice is that when I shift a, what actually is changing the most, what was most obvious to me, is that the y-intercept is changing each time. So meaning, if we know the value of a, we will also know where our graph is going to cross the y-axis, where its y-intercept is going to be. All right, so last thing I want you to notice is that as we adjust a, so as we go from 0, let's say we increase, what you'll notice is that the exponential function is also increasing. Now, if we shift a from 0 and we go towards -4, what you'll notice is that instead of increasing, the function now decreases. What's weird is it's almost like that function flipped, literally flipped, from one side of the graph to the other. And that's what a can do. So not only does it affect the y-intercept, but it also kind of changes the direction of this curve from an increasing curve to what we would call a decreasing curve. All right, ladies and gentlemen, this has been our introduction to exponential functions of the form f of x equals a times b to the x power. Hit me up on office hours Monday through Thursday from 2 to 3 if you have any questions, and I would be glad to go over them. All right, I've got another video coming soon. Take care. Talk to you soon.